All right, this is the first lecture of Unit 4, and it's about reaction types. And the really important thing to remember is this is not in your textbook, so this is your source of information for this lecture. Okay, so pause the video right now and copy down the general formulas, and then we'll talk about them. Okay, so the general formulas for our reactions. If you didn't pause, you need to pause now and do this. Okay, so the double replacement, we've already seen the double replacement reaction. We saw it with the acid-base reactions, but acid-base was like a special type of double replacement reaction. This is a compound, and it's reacting with another compound, and it's going to form two new compounds. And these are ionic compounds in here. And when we write an ionic compound, it always goes plus, minus, plus, minus. Okay, so we always list the positive ion first. And basically, if you look at this carefully, what we've done to get our products, see how we have AD over here on this side? Okay, so what we've done is we've taken A and we've put it with D, and then we have C and B. We took these guys. So this is kind of like foiling in algebra. Okay, first outside, inside, last. You're going to put the outside ones together and then the inside ones together. And the reason why it says CB instead of BC is because positive, negative, positive, negative. So when you write your formulas, make sure you always write your positive ion first. So we end up with two new compounds, okay? So that's a double replacement reaction. Synthesis reaction. When we talk about synthesis, we talk about synthesizing something. We're making it. And so we can recognize it because we have an element, and it's reacting with another element, and it's going to form the compound. So basically, you're going to take, most of the time, not all the time, you're going to take the ions that A and B form and use that to write its formula. And we'll show you some examples later. All right, decomposition. What do you think of when you think of something decomposing? Don't you think of it like breaking down? And look at the difference between the synthesis and the decomposition. How are they similar? Aren't they just flip-flop from each other? Okay, this is two elements forming a compound. This is a compound, and it is breaking up or decomposing into its elements. Okay, and no ions on the left side, no ions in your product side. Just write the elements as you would write them if they were all by themselves. So and we'll get back to that. All right, this is a single replacement reaction. So instead of two things being switched like they are in a double replacement reaction, only one thing's getting switched. And if you look here carefully, okay, the A is coming in and it's kicking the B out of the compound. So we have an element reacting with a compound, and it's forming a different element with a new compound. Same thing with the other example. It's still an element plus a compound element and a new compound. This time A kicked out C, and C's all by itself. So what's the difference between these two? That's kind of a tricky thing. All right, so since B is listed first, that's a metal. So this is a metal and a metal and a non-metal. And so the metal is going to replace the metal. Okay, and if you look over here, do you see how C is listed second? This is going to be a non-metal, and a metal and a non-metal. So the non-metal kicks out the non-metal. So let's just make ourselves a big old fatty note up here. Metals replace metals, and non-metals replace non-metals. So metals replace, and that's in a single replacement reaction. That's how when we get lazy, we just say single replacement. This is a double replacement. Synthesis, decomp. And then our last one is a combustion reaction. Combustion, you think of something burning, and what does everything need to burn? Some oxygen. Notice that all these are reacting with oxygen. Okay, so this is some metal plus oxygen. And this is, remember these were the hard ones to balance when we were balancing them before? So this is some carbon, hydrogen, oxygen compound. And this one's the easiest to predict the products because it's always, always, always carbon dioxide and water. It's super easy to remember. Okay, no excuse for missing that one unless you can't balance. All right, so that's just the general formulas. All right, so look at these and pause the video and try to identify based on, is it an element, compound, what's reacting, and see if you can figure out what each one is. All right, let's see how you did. All right, chlorine's an element, and it's reacting with sodium fluoride. That's a compound. So an element plus a compound, that's a single replacement reaction. You have methane, there's a CH compound, and it's burning with oxygen, so that's combustion. Iron 3 nitrate is a compound, and it's reacting with potassium carbonate, which is another compound, so that one's double replacement. You have aluminum combining with oxygen, so two elements. And so that's synthesis, but since it's reacting with oxygen also, it's combustion. Solid sodium oxide, so that's a compound. It's breaking down, there's a big hint there, so that's a decomposition reaction. And you have magnesium reacting with bromine, and that's a synthesis reaction. Okay, two elements reacting with each other, so they'll form a compound. Okay, so we're going to do some practice with predicting our products. Now, when you look at your products, the formulas for your reactants don't have to match the formulas for your products, but you have to have the same elements. So, and then don't forget, so make yourself a big note, big note. Don't forget your diatomics. All right, so back to our problem. We have chlorine gas. Chlorine is one of our elements. It's one of our diatomic elements. Chlorine gas reacts with aqueous sodium fluoride. So sodium is a 1 plus, fluorine is a 1 minus. So we're just going to put those together, and that's just going to become sodium fluoride. Okay, and it was aqueous. So that's going to form. All right, so this is a non-metal. This is a metal, and this is a non-metal. So the non-metal is going to kick out the non-metal. So fluorine is going to end up all by itself. F2. Why F2? Ask yourself, why is it F2? Plus sodium and chloride. And that's a 1 plus 1 minus deal, so we just go sodium chloride. Okay, and fluorine is a gas at room temperature. So there we go. Okay, we don't know what state the sodium chloride's in, so I'm just going to leave it right now. It's aqueous, by the way, but you don't know that. All right. So far, so good? So, no, it's not balanced. No, it is not balanced. Okay, when it does become balanced, we're going to put a 2 there and a 2 there, and that's where the other fluorine, where did this other fluorine come from? What happened to the other chlorine? Once you balance it, it all works out. All right, next one, methane, burns with oxygen. So methane, and we don't know what state of matter that is, so we'll just leave it, plus O2, because it's a diatomic. Okay, and remember we said this was a combustion, so this is like no-brainer. This one's easy, easy, easy. We just go carbon dioxide and water, and we're done. Except for it's not balanced. But carbon dioxide is a gas, water is a liquid. There we go. All right, so balanced, there would be a 2 here. It's up to you to check the balancing, okay? And that's 4 oxygen, so there's a 2 there. And it should be balanced. All right, let's keep going. We're almost there. Slides. Okay, so we said that this one was a double replacement. Remember, we already did that. So we have to write our formulas correctly. Iron 3 nitrate, FeNO3, 3, reacts with, oh, and it's aqueous. Let's put the little AQ there. That's an AQ. How about we just erase it and make it look like an AQ, huh? There we go. Now it's an AQ. Reacts with aqueous potassium carbonate. Okay. So remember, double replacement, we're going to FOIL. So the iron 3 is going to go with the carbonate, and the potassium is going to go with the nitrate. So we're going to have iron 3 carbonate, Fe2, CO3, 3, plus potassium nitrate, KNO3. Remember, it has to go plus, minus. So you always have to put your positive one first. Okay? And it is not balanced. We put a 2 here, and we put, that gives us 6 nitrates. So then, there we go. It's all balanced now. No, I expect you to do your atom counts and all that stuff. All right, we're almost there. Solid aluminum combines with oxygen. Okay, we have to write the formula for aluminum and oxygen together correctly. So remember, aluminum is Al3+, oxygen's O2-, so this becomes Al2O3. So don't worry about what it looked like on the left side. Don't worry about what it looked like on the left side. Write your formulas correct based on the ions. And then to balance it, we're going to put a 2 here, a 3 here, and a 4 there, and it's all balanced now. All right, last slide. Solid sodium oxide, not hydroxide, breaks down. So sodium oxide, because sodium's a 1+, oxygen's a 2-, breaks down. Okay, and it was a solid. They told us that. Okay, decomposition, we're just going to split this apart. So it's going to become sodium as an element, not as an ion, just the elemental form, plus oxygen. Remember, and the oxygen at room temperature is a gas. Okay, to balance it, we're going to put a 2 here and a 4 here, and it's all balanced. I know, it makes you sick. Sorry. But you will be able to do it like that with practice. All right, very last one. This one's so easy. You're going to love it. You're going to love it. All right. Magnesium. Okay, at room temperature, it's a solid. Reacts with bromine. Okay. Bromine's one of our 7 diatomics. Remember, we made ourselves a note. Remember those diatomics. Only when they're in their element state all by themselves. And bromine is one of those 2 that was a liquid. And that's going to form, okay, so 2 elements together, we're just going to squish them together and make them their molecules. So magnesium is a 2 plus, bromine is a minus, so this becomes MgBr2. And it's just chance that this one looks like it did on the reactant side, and it's all balanced. See, I told you were going to like this one. This one's not hard. All right, so first identify the type of reaction. That's going to help you figure out what to do. Okay, and then write your formulas correct. Don't forget to write your formulas correct. Don't forget your diatomics. And then go ahead and predict your products. And then you'll put in your states. Good to go? All right. Good luck on your homework.